All right, let's take a look at this comparative advantage spreadsheet model that I built for you. And then we'll take a look at a sample question on Cengage to see how we can apply it. So first, let me just show you the logic behind this. Then we'll walk through it with some numbers and we'll see how this is automating a lot of the arithmetic for us and making our lives easier so we can chug through this stuff faster. But most important is to understand the underlying logic. So what we've got here is a basic setup where we plug in basically the endpoints of a PPF. And we're going to assume a straight line, that means a constant trade-off between whatever good 1 and good 2 are, because it makes the math a lot easier. So with this, we plug in our basic information into here, what I've highlighted up at the top. We can change the name of the goods, and that will update as we go further down. Other things, all these things where you see it starts with an equal sign, those are formulas that are going to update automatically. Over here, we've got another spot for you to plug in your own numbers to evaluate different possibilities, and then it checks everything out for us down here. So let's take away the formulas and let's plug in some stuff. So to start, we'll say Rick and Eli are trading fish and coconuts. And notice how it's automatically filling stuff in for us. This is the big power of using the computer to do this, is it does all the grunt work for us once we do the setup. So we've got a hypothetical situation. Now we've got some hypothetical numbers. I'm going to start with something really easy. In this case, clearly I can produce more fish, let's call this per day. And clearly Eli can produce more coconuts, and so you don't even have to think hard. I should be making fish, Eli should be gathering coconuts, and we should be trading accordingly. So we've got these numbers. We'll plug in different numbers in a minute. Right off the bat, we've got some calculations figured out for us. So for me, if I produce one more fish, because I'm not producing the fish, catching the fish. If I catch one more fish, my not quite opportunity cost, but my trade-off is that I give up the opportunity to gather half a coconut. Right? Given these numbers here, if I spend my whole day on fish, I could get 10 fish. Whole day on coconuts, I could get 5 coconuts. So for me, it's a lot easier if I think about the endpoints of the PPF. So what's the cost of 10 fish? Well, it's 5 coconuts. Well, then what's the cost of 1 fish? It's 1/10 of that. So that's what the formula here is saying. The cost of 10 fish is 5 coconuts. The cost per fish is 5 coconuts divided by these 10 fish. And we're going to have similar things in all of these. This is just the reciprocal, but I could have done the same thing by saying the cost of 5 coconuts is 10 fish. The cost per 5, or the cost per coconut is 10 divided by 5 is 2 coconuts. Now, right here is really where the magic happens with the comparative advantage model. The key is that there are different trade-offs between our trading partners, and if we find the person who gives up less, in this case, I give up fewer coconuts per fish, and Eli gives up fewer fish per coconut, we trade accordingly. We specialize in what has the lower cost for us. Now, I say trade-off instead of opportunity cost because opportunity cost is the value foregone, and we don't know the value of fish and coconuts here, right? If Eli suddenly becomes vegan, the value of the fish is much, much lower to him, but the objective number of fish is still a trade-off in his production plans. That said, the textbook calls it opportunity cost, which is annoying, but don't worry about it. Just remember that we're kind of abusing the terminology there in a low stakes way. So we found my trade-offs. We've also found Eli's trade-offs. In this case, they just go the opposite direction. If we change our numbers, we will find that these numbers update for us. Right? So we're going to come back to 10, but let me just show you really quickly that even in a case where Eli has absolute advantage, he can produce more fish in a day. He could produce more coconuts in a day. He could even produce more fish and coconuts in a day if I make my PPF really small. but I still have a lower cost for one of the products compared to him. That is basically guaranteed. The one exception there would be if we have the exact same trade-off, then nobody has comparative advantage. Big takeaway here is absolute advantage absolutely doesn't matter when we're asking about how do we find gains from trade. So let's switch that back to 10 and 5. Use our original numbers. And so we see I have the lower cost for fish. And what's going on here is that we're calculating that since my cost is lower than Eli's cost, I have the comparative advantage and not Eli. Otherwise, it would be Eli. And in this one, we've got similar logic. It is also updating. Now, all this code down here, that's some hard to read stuff if you haven't used Excel before. Pro tip, if you're going to work in an office in the future, you're going to use Excel. So it is worth, not for this class, but for life skills, digging through this code a little bit to make sense of it. Or, you could just learn to, I don't know, dig ditches and not work in an office. So we've got this automatically calculating who has comparative advantage. Now, the real tricky part is how do we find a good trade? Now, here we can plug in different numbers. So here, if I give Eli 1 fish and 0 coconuts, and Eli gives me 0 fish and 1 coconut, that's one possible trade. And we could change this to say I give him 10, he gives me 10. I could give him 10 and 5, right? We can change this around however we want, and we can look later, lower on, and find out how that plays out. For now, let's just stick with what we've got in here. I'm going to give Eli 1 fish and no coconuts. He's going to give me no coconuts and 1 fish. Now, what I find is the easiest way to think about this is how much time are we taking for what we're giving up? And how much time would it take to produce what we're getting? So I'm going to ask, how much time does it take me to get 1 fish? And how much time would it take me to get 1 coconut? How much time does it take Eli to get 1 coconut? And how much time would it take him to get 1 fish on his own? So given this trade, I'm spending 1/10 of a day producing the fish that I'm giving up in this trade. Eli's spending 1/10 of his day on this also. But the time saved is based on what we're getting from the other person. So for me, I'm not saving any time on fish because Eli's not giving me fish, but I'm saving 20% of my day on coconuts. If I'd gotten 1 coconut myself, it would have taken me 20% of my day. Instead, I'm spending 1/10 of my day to give Eli a fish, and he's giving me a coconut that saves me 1/5 of my day. And since this is symmetric, right, it was 10 and 5 and 5 and 10, the numbers work out the same on both sides. So we're both spending 1/10 of our day and we're both saving 20% of our day. And the result of this is because we're saving more time than we're giving up, we are on net happy with this trade. Now we could do things slightly funny. We could say that I'm also going to give Eli a coconut and he's going to give me a fish. And in this case, it's a little bit different. In this case, we're just breaking even, so it's not quite as much as that. Let's make this 2 and 2. Right, so I'm going to give him 2 fish and 1 coconuts. He gives me 1 fish and 2 coconuts. That's kind of weird to do, but it means the net effect is that it's as though I'm giving him 1 fish and he's giving me 1 coconut. And we see that we're happy with that trade. Now, of course, it's silly for me to also give him a coconut and for him to give me a fish. But just to make the point of, we can make this a little bit more complicated if we want. And we should also say, of course, when we think about, say, international trade, some countries will export fish and import fish from the same trading partner. There's a probably different fish. In this case, we're dealing with ceteris paribus fish. We're holding all else equal. We're saying a fish is a fish, a coconut is a coconut. So we've got this hypothetical trade. We've got the time it takes each of us, the time it saves for each of us, and then this function here is just adding up each of our time costs and each of our time savings and asking, do we save more time than we spent? Cool. So we can plug in different numbers for this. So let's make me super productive. In this case, I just multiplied by 10. My trade-offs are exactly the same. Our trade is going to work out exactly the same as before, except now I'm spending a very small percentage of my time, but it's the same ratio, right? So it's still a mutually beneficial trade. We can change these in different ways. So we can ask, what if Eli gets better at fishing? Now our costs change. Our comparative advantage in this case didn't shift. If we kept increasing this, if we made this say 30, we're going to see our comparative advantage is going to flip. Right? Now that we've got a different set of numbers here, a different set of trade-offs, this trade is no longer mutually beneficial. In this case, I'm happy with it, but Eli isn't. So let's think about how we can make Eli happy with this. And for that, I'm going to show you a slightly different way of doing this. The textbook and videos online don't show this way. This is, as far as I know, something that only I do. This is my happy face table. So here, I'm going to think about I will be A, Eli will be B, and I'm going to give him some fish or coconuts. He's going to give me some fish or coconuts, and we're going to ask, how do we feel about that? Now, in this case, I'm not going to leverage the power of Excel. Instead, I'm just going to think through some possibilities. And the easiest thing to start with is thinking about the ends of our PPFs. So I'm going to start by looking, let me take a step back. What we want to find is some sort of a trade where we're both happy. What I'm going to start with is some trade that makes one of us indifferent, and then we'll find out if the other person is happy or not. So if I give Eli 100 fish, and Eli gives me back 50 coconuts, we have to include terms here because giving him 100 doesn't mean anything. Giving him 100 fish does mean something. In this case, whoops, that's not what I'm looking for. Indifferent face, right? Not a happy face, not a smiley face, not an unhappy face. In this case, I'm spending a day, I'm saving a day, I'm breaking even. Of course, I have to move these fish and these coconuts. I'm actually a little less than breaking even, but we're going to assume a can opener and forget about the transportation costs. So, how does Eli feel about this trade? Well, for him to get 100 fish, he'd have to spend more than 3 days. And for him to get 50 coconuts, he's going to spend about exactly 5 days. So Eli is giving me 5 days worth of work and saving himself about 3 days worth of work. He's going to be pretty unhappy about that. So let's try flip side, which should make Eli happy, which is where I give him 50 coconuts and he gives me 100 fish. Now it's going to take him multiple days to get all these coconuts and fish together. Don't worry about that. Again, it's the ratio that matters, not the absolute amount. Not the absolute amount. Don't get distracted by absolute advantage. Let's just verify that this is the right thing. So if I'm giving Eli 50 coconuts, that's something that's going to take him 5 days to do on his own. So I'm saving him 5 days of effort. And for him to get me these fish, it's going to take him 3.5 days. And so he is saving 5 days by spending 3.5 days. He is, in fact, going to be happy there. So what we've done here is we have essentially found out that I have a comparative advantage in fish. I got that right? Am I dyslexing myself here? A gives 50 coconuts. I might have gotten this backwards. It's easy to get this backwards, and hopefully it's helpful for you to see me make mistakes here. Let me verify. A gives to B a day's worth or a day's worth. I'm definitely confident that I'm indifferent here. A gives 3 days worth of fish to B. B spends 5 days, right? B is unhappy here. A is getting 5 days worth of coconuts and giving up 3.5 days worth of coconuts. All right, cool. I didn't make the mistake I thought I did, but even when you get it right, it's easy to flip these things upside down and backwards. There's another reason it's nice to have a spreadsheet that sorts it out for you. That way, you figure it out the one time, and then you don't have to confuse yourself over and over again for each new homework problem. All right, so we found one thing. Let's go with making trader B indifferent. And we'll try it both ways just to be consistent. So we'll say 30 fish for 10 coconuts, and then 10 coconuts for 30 fish. Both of these trades is going to make B indifferent because they're spending a day to save a day. They're giving up 1 day's worth of coconuts and getting 1 day's worth of fish as far as their own production possibilities are concerned. From A's perspective, we know that if B is unhappy here, A should be unhappy here because we're trading against comparative advantage, right? We're trying to do the thing that we're comparatively not as good at. A is absolutely more productive than B, but comparatively, fish per coconut, their costs are different, right? So A giving up less than a third of a day for fish, and they are saving less than a fifth of a day for coconuts, and that makes them unhappy, versus they're spending a fifth of a day to gather these coconuts, and they're saving about a third of a day for the fish that they receive in exchange. So they are happy in that case. So what we've seen at this point is it's very easy to find a trade that makes one side indifferent and the other side happy. Right? We might find the unhappy trade first, but then we just switch directions. It lines up with our comparative advantage, and now we've got something where there are gains from trade. So to make this mutually beneficial, we just need to split this so that the gains from trade go to both of them. So a really easy way to do this is to just sweeten the deal a little bit. So let's start by just ignoring these non-mutually beneficial trades. And we could take this one and make it a little bit better for A, maybe by saying they give up slightly fewer coconuts for the same amount of fish. In that case, A is now fairly happy. They're no longer breaking even, they're doing a little bit better. B is a little less happy than they would have been, but they are still happier than no trade at all. They are better off than they could be on their own. We could also change this so that one side is going to be, the other side is going to be happier, right? So we could take this one, and we just need to sweeten the deal for B just a little bit. So we could say A gives an extra coconut for these 30 fish. And in that case, both sides are happy. And of course, we could go the other way and take our bad trades and find one where both are unhappy, but there's not really any money in finding lose-lose situations. We want to find the win-win situation, and we did that here. So given that, we can come back, let's find one of these trades we liked. 49 coconuts for 100 fish. Let's try it out. 49 for 100 fish. And so now we can see that I am giving up 1 day, but I am saving 3 1/3 days. Eli is giving up 4.9 days. I'm giving up 1 day and saving 98% of the day. Eli is giving up 4.9 days and saving 3 1/3 days. And did I get this backwards? Possible trade. Oh yeah, given this other direction. See, it's still easy to get this backwards and forwards. Make this 100, 0, 49. So now, here we go. I'm giving up 98% of a day and saving a full day, which means that I'm happy. Eli's giving up 3 1/3 days, saving 4.9 days. That means Eli's happy. So let's go ahead and apply this to problem from here. A lot of the times these problems will kind of give you extra layers that will kind of be there just to make it a little bit more confusing, make you have to slow down and be careful in order to get to the right answer. But let's go ahead and plug this in. So hours needed, number of hours produced in 40 hours. This right-hand side is exactly what we want. It's basically the flip side of our PPF. It's giving us our endpoints. So now we want England and France, and they're making cheese and wine. If England spends 40 hours on cheese, they produce 40 units of cheese. If they spend 40 hours on wine, they only produce 8. And for France, those numbers are 5 and 20. So we've got our trade-offs here. Now let's think about these possible trades, right? So we've got this table, yada, yada, yada. Assume they both have 40 hours available. We could say France has 120 hours available, and we just multiply these numbers, but we're still going to get the same trade-offs. So if we have 3 times as many French workers, that becomes 15, that becomes 60. But notice 4 and 1 over 4, we get the same result in either case. So we'll stick with the numbers in the question. We can see England has comparative advantage in cheese. They should be selling cheese, not wine. All right, so at 0-0, no one's gaining because we're not trading. But let's see what happens if, what have we got? England specializes in cheese, France specializes in wine, and they trade 10 units of cheese for 8 units of wine. So 10 units of cheese for 8 units of wine. And we can see that for England, they are taking 1/4 of their weekly production time, and they are saving how much? They're saving 2 weeks worth of production time for the wine that they're getting. Or sorry, one week. I keep reading in the wrong direction. So they spend 1/4 of a day or 1/4 of a week, and they save a whole week. France spends 40% of a week, and they save 2 weeks. They are both happy with this trade. So France's gain from trade, well, let's think about that. How much are they getting? They are getting more cheese, and they are, well, let's think about their outcomes. This is something I don't have built into this. So if they're both going for here, this endpoint, then their net effect, go ahead and add some rows up above. New outcomes for England and France in terms of cheese and wine. Their cheese is going to be how much they could produce. Or let's see. England is going to only produce cheese, right? So start by putting that in. Their wine, they're going to be producing 0 wine, but we can add in the amount that they get from this trade. So in this trade, they are getting 8 units of wine, and France is getting 10 units of cheese. And England is going to be essentially netting this out. They're going to be ending up with 30 plus the 8 units of wine, and France is going to be ending up with 12 units of wine. Right? So we're getting essentially these two selves. Right? France spends all their time on wine, we get 20 units of wine. England spends all their time on cheese, we get 40 units of cheese. These numbers add up to that. I'm not going to automate that on the fly in front of you because this video will go on too long. So we compare that. What's our basis of comparison? Initially, they divide their time equally between cheese and wine. So this is their new outcome, and let's say their starting point. Their starting point was 40 divided by 2. And just half of what they could produce if they spent all their time producing cheese, plus half of what they could produce if they spent all their time making wine for each country. So our gains is just a matter of a little bit of subtraction. So England ends up with, well, clearly 10 more units of cheese than they would have had. And, oops, wrong way. And 4 more units of wine than they would have had. I might have messed up a negative sign there, but let's see if these numbers add up. All right, 7.5 plus 2, and we're thinking about France. That's going to be this one. Let's see, where did I get my negative sign? B6 minus B2. Okay, maybe I was right. Or new, that's right. I'm going the wrong direction through time. So we end up with 8 instead of 4, which means we gain 4. We end up with 12 instead of 10, which means we gain 2. So we have that answer. I'm going to check this. I've got a bunch of empty questions that I didn't answer, but let's go ahead and find question 16, and I got it right. Good. So that would have been embarrassing if I got it wrong. We can now see that with the spreadsheet, we set ourselves up to verify that this is in fact a mutually beneficial trade. Finding out how beneficial was a little bit of extra work, right? We had to name a starting point, and we could expand this. I think that's actually a really good educational activity, something you guys should try to help you wrap your head around this, is adding in this thing where given a possible trade, should probably go down towards the bottom, where we get some starting point, and given this trade, we get this new outcome being updated automatically, and then we get these gains from trade being updated automatically also. All right, so if that was a bit much, pause, ponder it a little bit, pause and rewind, try this out, fiddle with the numbers, and if you still have questions, go ahead and ask me in the usual places, and I will see you in the future.